Thank you, everyone, for giving us this opportunity here. It's an exciting day today, something that we have been working on for a while. And we have just announced this morning in the keynote at Cisco Live. It's really interesting that, in 2017, I was talking to some of you guys in a similar setting, and we introduced the Catalyst 9000. And that has become one of those products that has been consumed by hundreds of thousands of customers, super successful. And very shortly, it has become a super comprehensive portfolio with a line of products, a huge product family, and the amount of features and solutions that we have introduced on Cat 9000 is just unmatched. Well, what's happening in 2025 is slightly different than what was happening in 2017. And if you think about the workplaces that we have and the network that assists in the workplaces, the devices around us are changing. These were not the devices that we used to have around us in 2017 or even in 2020. Some of these are very visible, like robotic arms and more of a humanoid kind of devices starting to get into some of these environments. And some of these are very subtle, like your iPhone or your Samsung phone with AI running on it. And these devices, although from hardware perspective it is the same, from intelligence perspective and the way they are behaving is different. And so that's a change. We have also seen, one of the things that we are seeing a lot these days, I'm hearing from the customers, is Wi-Fi 7 is actually pushing the boundaries in real life beyond 1 gig. We have been talking about, since the start of Wi-Fi 6, 6E, theoretical limits, or theoretical performance. But now, if you plug in the port and in a normal environment, you will see more than 1 gig being pushed from the Wi-Fi 7 access points. And so it is the new standard for Wi-Fi is a multi-gigabit, and that's something that we also have to take into consideration. Another thing that's happening actually, interestingly, in this AI era, and I'll talk about AI in a second, but quantum computing is becoming a lot more relevant, especially from the network and security perspective. Quantum computing is great because it is going to solve those problems that takes years today in minutes or seconds once quantum computing is consumable. Today, it's there, but it's not consumable enough for the general public. But once it is going to be consumable, it is going to solve a lot of problems. But guess what? What is going to also happen is the bad actors will start using it as well. And so when the bad actors will start using quantum computing, they will try to exploit some of these some of the data, some of the algorithms that we have from security and cryptographic perspective with the help of quantum computing. And in fact, the problem is that threat of quantum computing actually starts right now. Because one of the threats that's actually happening today is harvest now, decrypt later, which means that the bad actors know that in the next 5 years, I'll probably have my hands on quantum compute. So why don't I just go and grab that data that I cannot read today, but I'll be able to break it in the next 5 years, right? And that's a huge problem. And a lot of public sector and financial institutions, you will see anybody who is keeping the data for a longer period of time, they are concerned. And there are new requirements and new compliances. And so that's something that we really need to look at when we look at the networks for the next generation. What we are also seeing is a rapid evolution of AI. Like if you think about AI, I mean, AI started in the 90s. You guys remember some of those chess competitions. But what happened in the last 2 years has been just, unprecedented. Like in the last 2.5 years, the amount of evolution that has happened in the AI field is just mind-boggling in some ways. And so we started with generative AI, but we are going more towards agentic AI, agents sitting next to us, like Jitu mentioned this morning. There may be 7 billion people on the planet, but maybe there are 70 billion agents around us in future. that changes a lot of things. That changes, first of all, the amount of traffic that is being generated by all of these agents, right? And so if you look at, and we have to do a lot of work here in this area, but if you start looking at the AI traffic today, in addition to the amount of traffic that is growing, the pattern of traffic is also changing. And the pattern of traffic, when you look at it and at the AI traffic today, there are a few things that are changing that makes us think what we have to do in the network. And one of the things is the reverse flow of the traffic, right? Typically, what we do is we send you pick your favorite URL, cisco.com. Cisco.com going up is just a couple of KBs, right? Kilobytes of data that's going up. But then you get the entire website down, which is several megs in some cases, right? And so that's the flow. The flow has been downlink, more traffic, uplink, very little traffic. But with the AI, the traffic is going in the reverse direction. Why? Because all these modalities of AI that we have, that is pushing the traffic, a lot of traffic up. So my wife talks to ChatGPT. That's why it's going up, right? We are uploading a lot of videos and pictures to the AI applications, and that's going the other way, right? And that's a change, right? And so we have to take care of that in the network. The network which has limited bandwidth are showing up more already. The network that has ample traffic bandwidth, that network will show some of these things in the future. The other thing is these are bursty traffic, right? But it's slightly different than bursty traffic. It's also latency sensitive traffic as well. So a deeper topic to go into, but to address all of these challenges that we have talked about, whether it's quantum, whether it's AI, whether it's new types of endpoints and applications around us, we have to look at the networks and how we are going to address it in the next decade, right? And so that's where we are starting a new Cisco switching series, and we introduced it today at Cisco Live in the keynote, and it is called Cisco C9000 Smart Switches, okay? So we are starting with two devices. Number one, the Cisco C9350. These are the stackable switches, and my team here is going to be talking about it a lot more. Kenny will go into it deeper. This is our next generation of stackables, and it's sitting right here. You can probably see it, if you are here at Cisco Live, you can see it in one of the solutions. It has many industry first. You will learn more about it later on. I'll keep it short here. But the second thing that we have introduced is called Cisco C9610. Those of you who remember the Catalyst 6509 and Catalyst 6513, or some of you guys have put Nexus 7700 in your campus core, this is the next generation for that, right? These devices, all of these three that I mentioned, they are coming very soon, end of support. Last day of support is coming in October. We are here to help you guys transition into this as soon as possible. But this is a 10-slot chassis, 2 for supervisor, 8 for line cards, 448 ports of 25 gig, and 256 ports of 100 gig that you can have on this one. And guess what? The backplane or the capacity of this box can take it all the way to 400 gig ports on all of these line card slots. So super rich from performance perspective, but it's also rich from some of the other things from security perspective that we will talk about. Yes, Christian. 400 gig when it is going to be launched. So today we are going to have very limited ports. Depending on the architecture, depending on the configuration of your ports, it can very well be non-blocking. So the amount of bandwidth that we have total is non-blocking. However, you have to look at how the ASICs are mapped, and Kenny and Sean will talk about it a little bit. And based on that, there are going to be some scenarios where it might have a little bit of oversubscription. Okay. So when we are introducing these things, I want to keep it very quick. We are also making sure that we are drawing a line and moving forward and introducing a unified way of managing these boxes, right? Something that we have not done in the past. In the past, we have had, Meraki product lines for cloud management, and then Catalyst product lines with Catalyst Center. But going forward, we are giving our customers a choice to go and select the right device that they need, the right hardware that they need for their requirements, and they will have the option to go manage it with the dashboard, with a CLI or API, or with Catalyst Center. That's customer choice, right? And that is something that is going to be very new, starting with Cisco C9000.
So Ben Starr here with Red Eye. So I assume there's thick walls between those three. We're not going to be able to, be on Catalyst Center or Meraki Dashboard and still access the console like we've. So is it traditional Meraki or is this traditional Catalyst?
Very good question. Those lines are blurring.
Okay.
Okay, and we are trying to make with the new one, you'll be able to get to the CLI while you also have access to the dashboard. Right?
So will you be allowed to make changes when it's offline to fix things and have it sync back up to the cloud, or is it still going to be read only from the console port?
It's not read only from the console port, and that's the change. Like in one of the previous modes that we have introduced in the past was that once you are, first of all, you had to wipe out and reload the box in a Meraki mode.
Yep.
We are making all of that process very, very simple, and some of it is going to be discussed a little bit later on. Okay. One of the other things that I wanted to show you, I know you guys will love this. The ASIC that we have on both of these devices, the 9610 and the 9350, are both Silicon One. Right? There are two types of Silicon One chips that we are using. This big one here, I'll pass it on in the room here. This is K100. This is 6.4 terabits per second. On the 9610, there are 4 of these. Okay, and so that's why you see the supervisor is a 2RU supervisor. Because we need to cool it down, right? It needs some air around it. Okay, so I'll pass it on. You can feel it, it's heavy. And then we have the second one, which is the A100, that is actually here on this box, the C9350, and I'll pass it on here. You guys can have a quick look as well.
So these are the same chips then that you're also using in the 8000 IOSXR routers, correct?
Some of the 8000s are using this, yes. Yeah, yeah. And Sean is going to talk about, silicon in a little bit more detail. Okay, and then it comes with IOSXC, and I'll not go into too much of this because Sean is planning to cover this as well. But IOSXC is being enhanced, it's bringing microservices, process modularity in the IOSXC system. It is also going to become quantum safe, right? So QPC compliance is something that we are going to bring at the operating system level as well, right? And then we have, application hosting that is going to be enhanced compared to the first version of the Cat9Ks that we introduced. So this is going to be a lot more capable. You'll be able to run multiple applications at the same time. Okay, I'll skip this just in the interest of time. When we introduced the Cisco smart switches, what we kept in mind is we need to have a hardware that is going to serve our customers for the next decade, right? That's for the AI era. And that's the hardware that we are bringing. And this is just a start. The second thing is security fused in the network, which means that all of these boxes are PQC compliant, right? For PQC, it's a larger topic, but I'll say it very briefly. PQC has multiple levels that you need to achieve. Some of it is in hardware, some of it is in software. These boxes have a chip that is going to make it a PQC compliant. These boxes are also Hypershield ready. Again, this is readiness, not Hypershield functionality. And then you guys have heard briefly compensating controls, G2 talking about it in keynote today. And that is on the roadmap. That is something that is going to help with the vulnerabilities fix quickly instead of waiting or upgrading. Like we have brought hard patches in the past, but right now we are with compensating controls. It'll be a matter of minutes to block it. And then finally, operational simplicity with platform flexibility, like I talked about it. So we are giving our customers a choice to manage all of these devices with the platform that they like. With that, I'll hand it over to Kenny to go deeper into 9350.
Where you go.
Yes.
Is it just the 9610, or do you have chassis that are small, that have fewer blades in them?
So we already have a very comprehensive Catalyst 9000, so that continues. With the new smart switches, at the moment, it is just the bigger chassis that we are introducing. Yeah.
On the roadmap?
You just created a new product here.
Good job.
It's probably either going to be the 9606 or the 9608, but yes.
You are giving me ideas. Thank you.
Excellent.
Now, speaking of size, are the 9350s the same length as the 9300s, or are we going to be replacing all of our wall mount racks again to
Yeah,
size?
so again, Kenny is going to be talking about it. There are a few differences. First of all, this is 18 RU. Depending on which one you're talking about, 6509, 6513, 77, Nexus 7700, these have different sizes. But one of the important things is this box is front to back airflow, okay, which aligns really well with where this box needs to go today,
right,
versus 6500 that used to go in the wiring closet a lot, right? So there are differences, and we have to kind of take care of some of those.
Thanks, Mohammed. My name is Kenny Lee. A very quick introduction. So I've been working with the switching for a good amount of time. So I actually, when we introduced a Catalyst 9000, I was initially working on that team. And subsequently, now we're introducing the Cisco's 9000. And okay, so Mohammed talked about that there are two models that we introduced, right? The 9350 and the 9610. So I'll go into the detail, specifically on a lot of the hardware related. And then Sean will go into more details after my 25-30 minutes later. And he will go into the ASIC and the IOSXC. What are the architecture differences in that? Okay, so here. So the first one Mohammed mentioned, this is the 9350s, right? What are the enhancements in that? The first, if you look at it, he talked about the Silicon One ASICs. And I heard some of you asking about, is this the ASICs being used on the other platforms? Yes. This is a Generation 2.0 network processing unit within the Silicon One family. So there is a lot of enhancements in there that's specifically for a campus environment, right? The hardware net flow, a much larger table size for the ACLs and so on, right? The ASIC itself is capable of 1.3 terabits, right? Obviously, if you look at the 9300, you look at all the front panel ports, you wouldn't be able to use all of this bandwidth. So your question might be, okay, why is this so big, high performance? The front panel has using some bandwidth, but there's also a stacking as well. So previous generation, we have 9300X up to 1 terabit of the stacking bandwidth. Now this one's up to 1.6. Okay, so front panel ports, all of them are line rate, so there's no oversubscriptions in here. In the back there, it's up to 1.6 terabits for the stacking bandwidth. Okay, scale-wise, we talk about that. Comparing to the existing 9300s, is 4 to 6 times higher in terms of the ACLs, in terms of the routing tables. And Sean will actually talk more about how we were able to get the ACL scale to be much higher, at the same time maintaining the same power footprints and so on. Okay. The stacking in here, Mohammed also mentioned, we're changing the stacking architecture, but the interface to the user remains the same. Right. Previously, we used our own proprietary for the stacking protocol, but now we're using the standard Ethernet-based protocol, which is VXLAN. Okay. So that opened up a lot of more possibilities. So let's leave it over here. So in the future, we might be able to write on top of this technology and give you more capabilities. Mohammed touched on the securities. I will have a little bit more touch on the security later on. Okay, so that's from the front, right? In the back, there are also additional enhancements that we have done. Okay, if you're looking at the stacking port, I mentioned that this is a 1.6T, but even in the stacking power, previously, I think if, you might have heard some of the customers saying, okay, stacking power is great, but there is, a limit of how much power we can send from one stack to the other stack. We have enhanced this, right? So now up to 55 amps, we can send it over to the other devices. High availability is a key in any of those networking elements. Right? The first one is now we have 3 fan modules is in here, and they acting as N+1, right? Any one of the fan fail is fine. Previously, all of them has 2 power supplies, right? Either you can run it on combined or redundant. But now we have 3 power supply, which is much more modular. You can have an N+1 redundancy. One of them is acting as a backup with the other one. Okay, so here's the architecture of it. The only thing that I wanted to point out to you is in some of the models, you might have multiple ASICs, right? In some of them, a single ASIC is capable of taking care of the entire thing. But in some of the other model, because out of the ASIC, even though it can do 1.3 terabits, it's about 500 gig is for the front panel port, and the rest of them is using for the stacking interface. So in some models, you might require 2 ASICs. So within that 2 ASICs, there are interconnection between the ASICs, and there's also additional bandwidth in the back there to take care of the stacking if you want to stack additional devices in there. On the right-hand side is very simple. This is the control plane, and on your left-hand side, this is the forwarding plane. Am I going too fast? We're good? All right. On the stacking, I mentioned a couple of things, right? 1.6T and also using the standard Ethernet, but there are additional things that we have enhanced with these technologies, okay? I use an example to go through it. Previously, when you do a stacking, you have to go from switch number 1, go to switch number 2, and then connection from 2 to 3, 4 to 5, and so on. And then from the very last one, go back to the first one. Right? This was a only way to connect a stacking in the existing 9300s. But with the new standard, that using the VXLAN as the standard protocol, and also using the shortest path for routing the traffic between the stacks. We are able to provide you additional flexibility. You can connect the stack any way you want it, right? Every switch has 2 ports in the stacking. As long as those 2 ports are connected, you can connect it any way you want it, right? The middle column gave you an example. It's like, I don't need a very long cable, right? At most, I only need to go to 3 switches. Okay. And the last one is like, oh, I can connect it any way you want it. Now, also, previously, in a failure case scenario, if one of the stacking cable failed previously, if this one failed, all of the switch stacking bandwidth now is half. Okay. But now, with the new stacking architectures, if the red one failed, only the switch with the red connection will have half of the stacking bandwidth. But the remaining one will still have a full stacking bandwidth of 1.6T.
Do you have recommended stacking patterns depending on the number of switches you have? Because like that architecture on the right, that makes sense for 4 switches.
Yeah.
When you have 6, you could replicate that down 1 more. Do you understand, like, and I'm sure there's a maximum number in the stack. Probably don't.
8 today, and we are looking to increase it to more.
Okay. We can talk about whether that's a good idea or not.
Yeah, that's exactly the same thing, right? If you reach about area domain, then you might not want to go there. But in some cases, customers do see a benefit. It's like, hey, I just need to add 1 more switch. do I build 2 stack or can I do it with 1 stack? I agree with you. We can talk.
We should talk to those customers too. But I'm just wondering that now that there's variability in the way that you deploy the back end, is Cisco providing recommended models depending on the number of switches or recommended connection architectures? Because like now all of a sudden there's variability to where there wasn't variability before. And I understand the value, not having the bandwidth on the back between the connections makes sense. Having it just be connected however you want is not great guidance to customers about how to do this. Okay. There's going to be better ways. You know, like that model on the right's great, but one of the ones you showed before was awful. I wouldn't do it that way, right? So if you don't, maybe something to think about is to provide guidance about how to connect those stacks on the backplane depending on the number of switches you have.
Absolutely. Well, certainly I can look into it, and because also depends on which module you have uplinks and so on, right? We need to take those into consideration. Maybe there is some best practice that we can provide instead of saying that, hey, you can do it any way you want it. Yes, you can do it any way you want it, but here is maybe the recommendation that we can give them.
Right. This one on the right is with purpose. Yeah. Like that's not accidental the way that those are connected. It's done for resiliency, as those cables may or may not fail going forward. Yeah. Like it's done with purpose. Some of those ones you showed before, sure, they may work, but that wasn't done with purpose. Like there's reasons to do it a particular way.
Absolutely.
Question, Josh from Diversified. Do you have any pictures or diagrams that also stacking horizontally? Because that may also come into play.
That is today
no.
It's not the horizontal. That's fine. Yeah. So this is all the vertical stack.
Stacking so much is smearing.
You know, when we talk about like making 2 different stacks, make a second stack.
And then maybe you'll be able to connect the 2 stack together, right? Okay.
Sorry, just one other real quick question with that. With the second the architecture on the right, that kind of implies that you could have up to 2 cable failures and still survive.
Well, if this one failed, let's say assume
it would split.
Yeah, this one failed, then the middle one is gone, right?
That's it.
But then but the rest of the 3 will still be working fine in it. Yeah. Any other questions? Good discussion, good feedback, by the way, too. Okay. Mohammed touched on the post-quantum cryptography compliance, right? The switch that on this 9K switch today, starting with the trust anchor module or the TAM module, within there is a SUDI, right? A secure unique identifier. That SUDI today is PQC compliance. Right? I put a little note on the bottom in here. That is what we use to sign for those. Subsequently, once the device starts booting up, right, there is a lot of the certificates in there because we have to check for the certificate for the OS, the image signing, the bootloaders, and so on and so forth. And then also on if we have we're going to support the MACsec and IPsec. For MACsec and IPsec, there's 2 ways to set it up, right? You can use a certificate or you can use a PCS strings, right? With the certificate, that also need to be PQC compliance. And when we introduce those features, those will be available within IOSXC, right? It's not going to be just specific for this specific hardware. But from the hardware level, within the TAM module, we have that built in. So the foundations is there. So any next layer you add that up to, those will be added as well. And Mohammed talked about the compensating control, right? You heard from the keynote today, the actual product name is called Cisco Live Protect. I will I give a little room between the Cisco Live. People might say Cisco Live and then Protect. It's Cisco Live Protect. And that is exactly what it is. And from G2, you heard that it is already available in the Nexus OS. Right? This compensating control or Cisco Live Protect is on a Linux kernel level. So once we have it available in one of the OS, those could be easily put it into the other, like IOSXCs or the routing IOSXRs, and all of this will be easy going through. The next slide, the last slide on the 9300 is the application hosting, right? For application hosting, you need a CPU, you need a DRAM, you need the storage, you need the data interfaces. With the 9350, we have enhanced the CPU, we have used a faster memory, and we enhanced the number of CPU you can use in there, and the KR port, which we saw the application port, where you can actually suck in the data so that this container can be processed those data. All of those get enhanced in here. This is the foundation where we'll be able to hold all of this next level of the security application, the next level of anything that is buzzword Gen AI related. Okay. All right, 9610. Okay, so all the security feature on all of this that I talk about on the 9300 are available on the 9610. Okay, so this is the chassis. Mohammed mentioned this is a 10-slot chassis with 2 supervisors in the middle, 8 slots on the top and bottom. The chassis is capable of doing 51.2 terabit per second. Okay, that's what the capability of the chassis. That translated into about 6.4 Ts per slot. So a question was asking, well, can you do the 400 gig align rates, right? The chassis is absolutely is no problem. Now we have to talk about the supervisor. When I go to the supervisor, I go through some of those key components. Okay, there are 2 versions of supervisors. One is what we call the SUP3. The other one is SUP3 XL. The SUP3 is based on the K100 ASIC, and the SUP3 is E100 ASIC. SUP3 XL is K100. The difference between the two are scale, and as well as the buffer memories. But the performance, the throughput is the same. So either one you're using, you get the same performance. And some of those scales is in here, you can see is 2 million routes and so on. Okay, Sean probably will go through a bit more details on that as well. And with this chassis is a centralized architecture, just like what we have with the existing modular platforms on the Catalyst family. So we're introducing 2 new line cards. So those would be a native line card with the this new chassis, but all your existing 9606 line card will be compatible in here with an adapter.
So they're compatible, but if we have a mixed stack of your new cards, your new supervisors, and your old cards, do the old cards reduce the performance of the overall platform?
No, it will not.
Okay.
Yeah. So this is the beauty of the centralized architecture. The supervisor is the one who control what amount of the bandwidth to each one of the slots, right? If the slot doesn't use the entire 3.2T, so be it. Okay. The fan, also in the fan tray, so Mohammed also mentioned this is a front to back airflow. There are 4 fan trays in the back there. They are acting as N+1 redundants, right? Any one that fan fail, the rest will continue to operate. Okay. This is just a cool picture, right? How do you do it with front to back airflows, right? You need actually open space in your backplane so that the air can actually flow from front to back. This is using a industrial first centralized cable backplane. Those are not traces. Those are actually physical cable. So when they bundle together, you have plenty of space. The air can flow naturally from the front to the back. Okay. And those cables, because they have a very high signal integrity, so they can carry a very high speed signal. So 100 gig SerDes in here is no problem at all. Okay, centralized architecture just kind of re-emphasize what we just said before, right? Everything's done in the supervisor. The line card, it just grab the data and send it to the supervisor. So the line card doesn't do any processing. It doesn't really matter. I send 1 gig versus I send 10 gig, it's good. Okay. The 2 supervisors, one is the E100, the other one is the K100. You look at the characteristics in here, right? The performance is the same. The difference in terms of the scale. One, the XL has a much higher scale. Similar if you're using the 6500, remember we have a SUP2T XL and then normal SUP2T. Right? For performance, it's the same. Okay, this is to the question you were asking on the performance. SUP3 and SUP3 XL does not take a full advantage of the chassis. The chassis is capable of 51.2T, but with here, we only take advantage of 25.6. Okay, so 25.6, that means 32 port of 100 gig alignment for each one of those 8 slots. Okay, your question is this non-blocking or full line rate? It depends on the traffic flow. So each one of those Silicon One ASIC, 4 of them, right, either K100 or E100, in the front facing has 6.4 T of bandwidth, but at the back there is 3.2 T. So now the case is, if all my traffic have to go across here, then the worst case is 2 to 1 oversubscribed. But you might not, traffic flow in here does not necessarily have to go out to the other ASICs, right? They could also be going in here and coming out here. And the way those ASIC mapping to the front panel port is this ASIC, the first ASIC, connected to all 1/4 of the front panel port on every single slot. And the second one is the second 1/4, and then the third is third 1/4. So even if I have a single line cuts in there, I have access to all the ASICs in here. So I can maximize the ASIC capabilities, even I have 1, 2, 3, 4 line cards.
And you're building your line cards in such a fashion that if it's not a 48 port, if you only have 4 ports, it'll be 1 per ASIC.
They will still using it, low balancing. So if you look at some of the combo line card, right, it's not exactly 1/4 of the ports, it's 1/4 of the bandwidth will be connected to the first ASIC, right? Because some of them we have a 400 gig, 100 gig uplink, and then SFP is a downlinks, right? If you remember on the combo line cards on the 9606, even the same thing in here, the initial line cards. So they will have not exactly the number of ports, but the amount of bandwidth, 1/4 of bandwidth will be connected to the first ASIC, 1/4 will connect to the second ASIC. It's kind of make it much easier for the customer when you're deploying. I don't have to worry.
Yeah, it definitely goes to some interesting design patterns in terms of how to remember where you're mapping ports to.
Yes, a lot of people do have that question. So that gave them a good idea when I'm doing connecting the device to it. What port should I use, to maximize the capability on the uplink as well as the downlinks. So those are the line card on the existing 9606 line card. They can be used on this 9610 chassis. Okay, there is a carrier module that is required because the form factor of this is a little smaller. Okay, we talk about the power. All the power supply that is on the 9606 is the same power supplies used in here. The addition in here is we have added an N+N redundancy. We usually have combined as well N+1, right? N+N, if you have 2 power source, I can put one into a outlet power. The other one could be my power generators. So it gave you additional high availabilities in there. The fan tray, I talk about it, is naturally front to back. It's N+1 redundant. Okay, Stack-wise virtual, using the same technology as the Stack-wise, also is a standard base. Okay, the additional benefit from here, just right away, is you can dynamically add the Stack-wise virtual link as well as the SVL link as well as a dual active detection links. Right? Previously, if you change your number, if you add the links in there, you have to reload the system. Now you can dynamically add and remove them. Application hosting, this is a huge improvement from the previous one. Right? Started out with, well, of course, faster CPU. We also have more CPU you can dedicate for this, memory, but the next 2 component is dramatically different. Okay, the storage, the SSD, now is few replaceable units. Right? You push a little button in the front, it pops out this SSD, just like in the UCS form factor SSD. Okay. The other one is previously, if you want to do an app hosting, you have to use a loopback cable to get the data from the system data into the CPU so that it can process it. Now we have 2 internal connections, right? I'm only advertising 2 internal, and we're saying it's up to 10 gig. Actually, the capability is even higher. But we just see, we're looking at the applications, like with the amount of CPU core that you dedicate to it, can you actually process this much of a power, much of data? Okay. 3 more slides. The first one is, there was a question on a unifying onboarding, right? The Meraki Dashboard versus the Catalyst Center. All of this 9350 as well later on with the 9610 can be onboarded to both of them, okay, natively. So PV today, right, you have to go into if you bought a non-dash-M model, you bought a Catalyst 9300, you go in there and then issue a command, Meraki, register Meraki, and then you connect it to the dashboard. Then you can claim it on the dashboard. With this, it will be naturally, you can claim on either one, and I'll go through an animation slide in the next one. And if you wanted to switch in between two, you can do so as well. Okay. When you get the switch, when it boots up, the switch will automatically create a TLS, a tunnel to the dashboard, an SSL tunnel to the Catalyst Center, and also a TLS to the dashboard. Okay, that's assume you have internet connections in this environment. When you connect any of the front panel port to it, and there's already you have an IP addresses in there or DHCP, he get an IP address. Right, most of our device when we put in an environment, you have a DHCP servers is in there already. So I get an IP address. The switch when it boots up, it initiates a connection to the dashboard. And internally, if you have a Catalyst Center PnP running, it will also initiate the connections in here. Now it's up to the user. If I am traditionally a Catalyst Center user, I can go into Catalyst Center and say, add this device in my inventory, put it in my network. If you did that, then that tunnel will be terminated. But if I am a Meraki user, I go into my Meraki dashboard and claim this device into my inventory and assign it to the network. Now the switch basically say, hey, I've been told that dashboard is where my command is. Then I terminate this part of the connection. So it's very naturally, it's a single device. How you wanted to manage it, it's up to you now. You don't have to do any more manual works in here. I actually talk about this one. So this is we actually talk about this one. This is the, with the SUDIs, right? So we have the PQC signed in there. And then subsequently for the other features, those will come in the roadmap.
A question, Josh
Yes.
from Diversified. And on your slide here, you have a roadmap in the top right-hand corner.
Yes.
Since this is like a foundational piece of hardware just of how the switch works, and this is part of roadmap, do you have any dates that you could share with us on what that means? If not, that's okay, understood.
Yeah, I might not have the data for the rest of the, so when I say roadmap, it's actually referring to, because there are multiple components will come later. Today, this SUDI, the hardware itself is there. So that one is there. The rest of the component, once we do the micro loaders, right, where this one comes in, this one will come in first. And then the rest of them will probably come in around the same time. But the MACsec and the IPsec, that will probably at least, I would say, 6 months later, probably. So those will come in much quicker. But I don't have a definite answer.
So your roadmap's just, again, referring to the different components of
Yes.
how you're going to replace
How we're going to do it, yeah.
modules along the way.
Yeah.
Okay.
You probably will not get all of this at once, right? It would be like incremental. Once this one is well defined, we have this one. And then when the IPsec, when the MACsec comes in, and we will have that additional components.
Okay, perfect. Thank you.
Cool. Any other questions for me?